Questions 21 through 25 on the 2008 Grade 10 Cayley Math Contest. The circular window shown in the diagram has 9 panes of equal area. The inner circular pane has a radius 20 centimeters and the same center O as the outer circle. The 8 lines separating the outer panes are of equal length, x centimeters, and all, if extended, would pass through O. What is the value of x to the nearest tenth? So, first and foremost, what we need to do is join these 2 lines like that. And we'll label that R right there. That will be the radius of that small circle. And they tell us what is R. They tell us it's 20. So there we go. That piece of information will come in handy because we can calculate the area of that small circle. This one right here. That small circle in the middle. So it'll be pi times 20 squared, which is 400 pi. Now, this sentence is very important. 9 panes of equal area. So that means that each one of these is equal in terms of its area. These guys that all have the same shape and this circle. So that means each of those guys that looks like this is also equal to 400 pi. So how many of those do we have? Well, they tell you there's 9. Well, there's 8 of these, and then there's a 9th shape that's in the middle. So the total area is 9 times 400 pi, correct? And that's 3600 pi. And that is equal to pi big R squared, where big R is the radius of the big circle. So it would basically be from here to here. We call that big R. And we can solve for this. Pi big R squared, well, the pi's cancel first of all. So you're just left with R squared is equal to 3600. And if you take the square root, R will be equal to 60. Okay? So R is 60, that's small r, and then this length here is x. So that means small r plus x is equal to big R. Small r is 20, big R is 60, and therefore x is 60 minus 20, which is 40. Exactly 40. So number 21, the answer is A. Suppose that n is equal to 1 plus 11 plus 101 plus 1001 plus 10001 all the way till you get to this big long number which has 50 zeros in it and 1 on opposite ends of the number. When n is calculated and written as a single integer, the sum of its digits is. So what I'm going to do is I'm going to write out these numbers sort of one on top of another. Kind of like the way you learned addition when you were in grade 1 or kindergarten. So the first one is this guy right here. So just how they put it, I'll just say 50 zeros. And then the next one that's a little bit smaller will look like this, right? It will be like that. And then similarly, the next one that's 1 digit less will look like this. Correct? And so on. You get the point. And then eventually I'll skip a whole bunch, ... and I'll just write 10001, these guys that they just gave me, 5 of those, right? So 1001, 101, 11, and finally 1. And then at the very end, I will figure out the sum. And that sum is that single integer. Okay, so first and foremost, how many digits do each of these numbers have? That's going to be very important. Well, this guy right here has 52 digits. How do I know that? Well, there's 50 zeros, but then we've got a 1 on either side. So 50 zeros plus 2 ones, 52. This one has 51 digits because it's just 1 digit less. And so on. You get the point. 50 digits, 49 digits. And then these ones, you can just count them. 5, 4, 3, 2, 1. Okay? Now we add these just like how you would back in the early days of elementary school. So that is all ones. Now how many ones are there? 52, because these numbers, there's 52 of them. You can clearly see that. So I've got 52 ones, so 52 ones is 52. So the 2 goes here, carry the 5. Okay? Then now I have to add this column. Well, there's only a 5 and a 1, so that's a 6. Then I have to add this column. There's only one 1, so that's going to be a 1. Add this column, again, only 1, 1. And it just keeps on going like that. Every column will be a whole bunch of zeros and then just 1, 1. 1, 1, 1, 1, like that. So this is my final integer. This final integer essentially is going to be 52 digits, right? And all of them are 1 except the last 2. So we have 51s when you're adding the digits, plus a 6 plus a 2. So that looks like 50 plus 8, which is 58. So 58 is the sum of the digits of that big long integer. And therefore number 22, the answer is D. If x and y are integers with y minus 1 to the power of x plus y is equal to 4 to the power of 3, then the number of possible values for x is. So we've got y minus 1 to the power of x plus y is equal to 4 to the power of 3. Well, 4 to the power of 3 is 64. So something to the power of something equals 64. Well, what are the possible ways that can happen? One is 64 to the power of 1. That would do that. 8 to the power of 2. 4 to the power of 3, which is what they gave us actually. That one, they give you that. 2 to the power of 6. Any more? Yes or no? See, this question is actually not that difficult. The only thing that I think makes people get this wrong is that they stop right there. They say, okay, let me just figure it out. And they get an x value for each of these, which I will show you how to do. And they circle C and they move on. Unfortunately, in a very heartbreaking way, that is the incorrect answer. And the reason is the average student, well, I don't know. I mean, I can't tell you if it's the average student, but I'm sure several students would miss. There's 2 more scenarios that you can get 64. And those are negative 2 to the power of 6. Remember, that is also a possibility. And negative 8 to the power of 2. So those 2, like I said, it's not extremely difficult, but a lot of students would miss that. So each of these is going to give you a value of x, and that means the answer is E. But of course, I have to show you how. So let's start with the first one. So for the first one, we have y minus 1, x plus y is equal to 64 to the power of 1, right? So that basically means y minus 1 is 64, and x plus y is equal to 1. This one immediately gives you that y is equal to 65. Substitute that into there, and you get x is equal to minus 64. All right? So that's the first one. And in a very similar way, I'll do the next few fairly quickly. Y minus 1 is 8, so y is 9. And then x plus y is equal to 2. I'm doing this one now. And therefore x is equal to minus 7. So that's another one. The next one, this guy right here, y minus 1 is equal to 4, so y is equal to 5. X plus y is equal to 3, and therefore x is equal to minus 2. Keep on going here. Y minus 1 is equal to 2, therefore y is equal to 3, and therefore x plus y is equal to 6, and that means x is equal to 3. And then, of course, these guys that a lot of students would miss, that one will give you y minus 1 is equal to negative 2, therefore y is equal to negative 1, x plus y is equal to 6, and therefore x is equal to 7. And then finally, y minus 1 is equal to negative 8. Y is therefore negative 7. X plus y is equal to 2. And therefore x is equal to 9 if I have done my math correctly. So I got how many values? 1, 2, 3, 4, 5, 6. So each of these gave an integer value. The only thing I was concerned is that one of these might not give an integer. That's why I calculated all of them. So the answer is 6 for number 23, which is choice E. A cube has edges of length 1 centimeter and has a dot marked on the center of the top face. The cube is sitting on a flat table. The cube is rolled without lifting or slipping in one direction so that at least 2 of its vertices are always touching the table. The cube is rolled until the dot is again on the top face. The length in centimeters of the path traveled by the dot is. All right. Let's see here. I'm going to draw some cubes. And then now let's talk about that. What kind of color is it? Did they say the dot has a color? No. All right, that's okay. I'll make it red. Okay, so here's my dot. I hope you can see that dot right there. So now what we have to figure out is when this cube is rolled, where do the dots end up? So for example, this is right here for this first cube. But when it's rolled, it's going to land here. Okay? Does that make sense? It's essentially just goes from here down to there. And I guess this is the frame of reference. That's the edge that it's going to rotate on. And if that happens, the red dot will end up here. Okay? So that's the first one. The next one is when this shape right here, again, rolls. And this is my frame of reference this time. It's just going to flat fall there. So that red dot now gets here. Okay? Then we can kind of do it in a way so that this now comes up here when you do another flip. And therefore the red dot then becomes here. And then finally, we're going to have a situation where this side will eventually flip and get to this point. So then the red dot comes here. Okay? So that is my pattern. I'm going to try to draw a little trajectory here. It won't be super accurate, but you'll get the point. The first one is going to be like this, right? The next one is going to be like this, and then the next one is like this, and then finally we've got like that. Now we have to somehow figure out that total distance. And how do we do that? Well, I'm going to call each of these a different number. This distance here, I'm just going to call 1. This distance here, I'll call 2. This one 3. And this one 4. Okay, I'll give you a little hint. 2 of these are the same, and the other 2 are the same. But we don't need to worry about that so much right now. Let's just concentrate on figuring out each of these. So first what I'll do is I'll concentrate on 2 and 3, because I think those are a little bit easier. And then I'll talk about 1 and 4. And then we just add them all up. Okay. So 1 and 2, 2 and 3, those are the ones I want to talk about. Those are pretty straightforward. Why? Because they just represent a quarter of a circle. You notice how they're just the diameter, the circumference of a quarter circle. So number 2 is circumference divided by 4. And C is the exact same. So these two are basically the same. All right, but what is the circumference? Well, circumference is given as 2 times pi r, or pi times 2r, whichever way you want to write it, over 4. So if I can figure out what is the radius, I'm done with that. Well, what is the radius of this circle? Well, it's from here to here, right? And they tell you that the entire edge is length 1. And they told you that dot is in the center. So that means from here to here is a half. So just put that in there, 1 over 2. and that represents the radius of the circle that we are talking about. So there we go. We've got pi over 2 times a half, so this is pi over 4. And similarly, 3 is identical, therefore it's also pi over 4. So we got 2 and 3 done pretty quickly. Now 1 and 4 are a little bit more challenging. That takes a little bit more of a careful look at this question. Okay, before I move to 1 and 4, I want to go back and look at 2. When you went from, for example, here to here, you went how many degrees? That's my question. Well, 90 degrees, correct? So in a very similar way, when you go from here to here, which would calculate our distance number 1, you're going 90 degrees. And that is very helpful to figure out the fact that this is also going to be a circumference over 4. And so we'll number 4 over there. But how are we going to figure out the radius? That's the challenging part. Well, what we have to do is figure out a reference point, and that reference point is right here. I'll draw a line from there to there. That is going to be 90 degrees. Okay? It has to be 90 degrees because when you're flipping the cube, you're basically going 90 degrees each time. And this shape that I just drew is a quarter circle. And it's a quarter circle where this is the radius right there. So if I can figure out that radius in terms of a numerical value, I'll be able to figure out that c over 4. Well, how do I figure out this distance right there? Well, that distance can be easily figured out using Pythagoras with this triangle. And that triangle is going to be this one right here. That one right there. I'll call this big R. The distance from here to there, that's just 1 because that's the length of the cube. The distance from here to here is a half. And it's not perfectly drawn to scale, but that's okay. You understand. Okay, let's figure out R first. I can do that up here. R squared is 1 squared plus a half squared. So therefore, that's 5 over 4. So that means that R is root 5 over 2. So put that into my equation here. So pi over 2, root 5 over 2. And therefore, that's root 5 over 4 pi. And for this guy is exactly the same. So that's also root 5, 4 pi. And now we have to just add them all up. So these 4, we're going to add up. And that's going to be 2 pi over 4 plus 2 root 5 over 4. And factor out a pi. And I think you can factor out or cancel these. So it just becomes a half and root 5 over 2. Yeah, that's it. So this becomes 1 plus root 5 over 2. Pi times 1 plus root 5 over 2, and that is choice E. Pi times 1 plus root 5 over 2, right. The average value of a minus b squared plus b minus c squared plus c minus d squared plus d minus e squared plus e minus f squared plus f minus g squared over all possible arrangements a, b, c, d, e, f, g of the 7 numbers 1, 2, 3, 11, 12, 13, 14 is. All right. So what I'm going to do is, instead of dealing with this big long mess here, which is going to get very confusing very quickly, I'm going to start with a small example. Let's say we have just a minus b squared and b minus c squared. That's all we have. Let's say. Okay, and then once I explain this, hopefully you'll understand it, and then we can extrapolate to this big long mess right there. And let's say instead of 7 numbers, I only have 3. I've just got a, b, and c. And we'll just be consistent. We'll choose some of these numbers here. We'll just choose those guys, 2, 3, and 11, right? The numbers are not that important. What's important is trying to understand how to do this question. So first and foremost, we have to figure out in my example, how many permutations are there? How many possible arrangements? Well, when there's only 3, it's pretty quick. For the first number, I've got 3 possible choices. Second number, 2 choices. And for the last number, 1. So 3 times 2, which is 3 factorial, which is equal to 6. And I can even write them out since there's so few. The combinations are 2, 3, 11, 2, 11, 3, 3, 2, 11, 3, 11, 2, or 11, 2, 3, 11, 3, 2. Right? There's only 6. I can easily write them out. So this represents 3 factorial, which is 6 possible arrangements. Okay, so far so good. Now we have to look at this guy. Okay, shouldn't take us that long. 2 minus 3 squared plus 3 minus 11 squared, right? I'll basically write these out. 2 minus 11 squared plus 11 minus 3 squared, and so on. And let's figure out what these are. So that looks like 1 plus 64, correct? And that is 65. So we'll make a little table here. Let me just separate that. And then this one looks like 81 plus 64, and that is equal to 145. The numbers, like I keep saying, are not important. What is important to understand a pattern, and then we can extrapolate that pattern onto the bigger question, which is this whole long thing and 7 numbers. So 1 plus 81, 82. Moving right along, we get 64 and 11, 64 and 81, I should say, and that's 145. And then this one is 81 and 1, and that is 82. And finally, 64 and 1, so that's 65. Okay, now, how do I figure out the average? Well, you know that. You know that because the numbers are so manageable, we can figure out the average fairly quickly here. You add up these numbers, and then you divide by 6, right? So it would be, let me just look at it from the standpoint of these guys. I don't want to look at those numbers because these numbers have a little bit more meaning to me than these numbers here. First and foremost, I've noticed very quickly that the numbers tend to be the same. Like the same number tends to appear. I got 4 64s if I'm adding all these up. I also noticed I've got 4 1s. So 4 times 1. And then I've got 4 81s, like that. So 4 81s. And so this is my total sum. And then, of course, I just have to divide by the total number of arrangements, which in this case was 6. So if my question was this simple, I could just do it. But what I want to show is what is the general. In the denominator, it will be the total number of cases. So it will be n factorial, where n is the number of numbers. In my case, it was 3. In the numerator, it will be basically, we can factor out a 4, right? So our general formula is going to be the sum of all possible values of a minus b, right? Divided by n factorial. And then we've got this 4 in there, but when we extrapolate, that 4 will make a little bit more sense. It will not be a 4 always, but what you put here will make a little bit more sense. But this is definitely very straightforward, and this, I hope, makes sense. The sum of all possible values of a minus b. In our case, here's a minus b, right? It could have been a 1, an 81, or a 64. Those are the only possible values for a minus b, and that's what we did. 1, 81, and 64. We just factored the 4. So this is our general formula. The only thing we have to do now is figure out what this number is going to be for our question, which involves 7 numbers instead of the 3 that I gave in my example. So to look at 7 numbers, what we are going to do is just concentrate on 2. Because remember, we only have to worry about a minus b. Everything else will fall into place. So I will choose any a and any b from this list here. And just look at those two. That's it. That's all I need to do. So let's just say I chose 1 and 2, right? That means the other numbers, which are 3, 11, we have to figure out how many arrangements are there. But 1 and 2, I'm sticking them together. So that is sort of being treated like one unit. So I've really got to place 6 different numbers together. And I have to figure out how many possible ways of doing that. Well, 6 times 5 times 4 times 3 times 2 times 1. Okay, and that is 6 factorial. So there's 6 factorial ways of arranging these numbers if I stick 2 of them together and say that those 2 numbers must be side by side. But AB can also be represented as BA, which is 2, 1. And then, of course, the other 5 numbers in any order. And if you do this, again, it'll be exactly the same in terms of the number of possible combinations. 6 times 5 times 4. So there you go, another 6 factorial. So together, it's 2 times 6 factorial ways of arranging 2 numbers together and those other 5 numbers. All right, so why did I do this? Because I want to be able to fit this in to my formula. The good news is that this number goes up here. Where does it go? Right here. Before I calculated and I got a 4, this time, this is the number. That's how many different possible ways that I can arrange 2 numbers, AB. So my formula, which is right up here, immediately becomes 2 times 6 factorial times the sum of all possible values of a minus b, squared that is, all over n factorial. Well, n factorial we can figure out. N is 7, so it'll be 7 factorial. So there we go. We are very close to figuring out this question. All we have to do now is figure out what's in this bracket, the sum of all possible values of a minus b. So that's what we will do next. Well, how do we do that? Well, what are the possible values? 1, 2, 3, 11, 12, 13, 14, right? These are our numbers. So we have to figure out all the possible values of a minus b. Okay? A minus b squared. We could have 1 minus 2, right? These two guys. 1 minus 3. And if you do and you figure these out, you get 1, 4, 100, 121, 144, and 169. Okay? And in a very similar way, you can figure out all the rest. 2 and 3, right? 2 and 11, and so on. And if you do that, you get 181, 100, 121, 144, like that. And similarly, we've got 3 and 11, 3 minus 12, and so on. And I don't think we have that many more. We have 11 minus 12, 11 minus 13, 11 minus 14. And if I do that, I get the following numbers. I get 1, 4, and 9. And then finally, I think I've got just a few more. 12 minus 13 squared, 12 minus 14 squared. And those give me values of 1 and 4. And the very last one is 13 minus 14 squared, which is giving me a value of 1. Now I have to add all these up. Very similar to my original example. I had to figure out all the sums. I have to add all these sums up. So I've got to add these guys all. This, and this. And if you do, you get a total of 1372. So going back to our formula, this 1372 represents what? It represents this guy right here. The sum of all possible values of a minus b. So I guess I can Stick it right there. So I've got 2 times 6 factorial times 1372 all over 7 factorial. And this should be able to figure out pretty quickly because these two cancel and just leave a 7. And then on the top I got 2 times 1372. And that is going to be pretty quick to figure out. 392. There you go. 392 is the answer to this question. And therefore that would be choice D.